Hey guys, you're watching Observing Space with Seth Holton. What's that over there? Space. Look at it. What do you see? Stars? Galaxies? Supernovas? Black holes? Quasars? Look at this picture. This is the farthest galaxy we've ever seen. How we look at that? It's telescopes. You knew that. Here's an artist's rendition of the inner workings of a refractor telescope. Telescopes can observe light that left objects extremely far away in the universe from billions of years ago by focusing on the same area for long periods of time. These are called deep field observations. The Hubble Ultra Deep Field is the deepest portrait of the universe ever taken. It includes some of the first galaxies that emerged from the Dark Ages, the period of time right after the Big Bang, when there were only stars to light the universe. Scientists studying HUDF divided the galaxies into time periods, which allowed us to view their evolutionary stages in real life. The galaxies we see today are majestic spiral and elliptical galaxies, and the early galaxies are small and weird. Think back to that picture I showed you earlier of the farthest galaxy ever observed. Look at that thing. What the hell? Remember when I mentioned the creation of deep fields? Light, especially light that travels thousands of light years through the universe, takes a lot of time to be collected in order to produce a clear image. In order to track an object for a prolonged period of time, the telescope's polar axis is driven by an electric motor at a rate equal to the rate of rotation of Earth with respect to the stars. This galaxy, Galaxy GNZ11, is the farthest galaxy we've ever seen. That also means it's the oldest galaxy we've ever seen. We are viewing what looked like 13 billion years ago, because it's 13 billion light years away. Now, you're probably wondering, how do astronomers measure something that far away just by observing it? They use a phenomenon called redshift to calculate distance. Let me explain redshift like this. The Doppler effect is the change in frequency of a wavelength in relation to either the observer moving or the object that is emitting the wave moving, depicted in this diagram. An example of the Doppler effect is when you are next to a fire truck that is driving away. As it gets farther away, the siren seems to get deeper and quieter. That is because the wavelength is stretched, making a deeper sound. Redshift is essentially the Doppler effect for light. When the wavelength is stretched, the light appears as red, and when the wavelength is compressed, the light appears as blue, aka blue shift. However, redshifting in space does not just happen because of the Doppler effect, but rather because of the expansion of the universe. Doppler shifts are usually from the motion of the source, and while that happens, the astronomical redshifts are mostly due to the expansion of space. That means that an object in space can be perfectly stationary and still experience redshifting.